As you can see from the title of this lesson, this is a tutorial on doing gas stoichiometry at STP. One of the first things that we will cover in this chapter, gas stoich at STP, all revolves around a central idea that we are able to do conversions among gases just like we are among solids and liquids, with one additional add. If you take a look at our mole box, many of the things we've covered this year are already on here. 1 mole is equal to Avogadro's number, 6.022 times 10 to the 23rd atoms or molecules. 1 mole of various molecules or elements are always equal to their number off the periodic table, or in the case of oxygen, nitrogen, hydrogen, which are Hoperfinkel's, you double their mass. Hence, a mole of oxygen is equal to 32.0 grams, nitrogen 28.01, hydrogen 2.016, helium 4.00. The newest thing that we're going to understand is that 1 mole of a gas at STP possesses a certain volume. If you remember STP from last chapter, it stands for standard temperature and pressure. Standard temperature is 0 degrees Celsius and standard pressure is 1 atmosphere. As long as you remain at those conditions, 1 mole of a gas will be worth 22.414 liters of volume, regardless of the identity of the gas. What that means is this. If I took a mole of oxygen and injected it into this box, which so happens to be exactly 22.414 liters, 1 mole of oxygen gas would make this box weigh 32.0 grams per mole. If I were to evacuate that and replace it with nitrogen, the nitrogen would still take up the same volume, right, but 1 mole of it would only make it weigh 28.01 grams per mole. Hydrogen is a much lighter gas than either of the two we mentioned. Hydrogens would only weigh 2.016, but would still take up this same exact volume as we go through. All right, this leads us to a new type of conversion problem where you can calculate not only grams and moles of gases, liquids, and solids, but we can get much more practical about what we do in the sense that oxygen, nitrogen, chlorine, things of that nature tend to be gases. It's not logical to measure grams of a gas. Right? What is logical is to measure volumes of gases. So these conversions involve the idea of changing volumes of gases into masses, or the reverse, taking masses of things and turning them into volumes. Right? There's a big series of handouts in this chapter. If you go to the notes section of chapter 11, print out the first few. Right? I am working off of number 2, which says gas stoich at STP. First question on there says, determine the density in grams per liter of CO2 at STP. When we try to solve a problem like this, what we are going to do is attempt to set it up like all of our other bracket problems from the beginning of the year. All of those started the same way. We list what we know, and we list what we're trying to find. If I look at that question, I don't know any numbers, so I would jump immediately to what is it I'm trying to find. And the question is asking me to find the density in grams per liter of the CO2. If I'm not given anything except for the identity of a gas, I have to create a number, right, that I can work with to begin. And most often, whenever we have the identity of a molecule, identity of a substance, we can go to the periodic table to get some numbers. So if I take carbon, which is 12.01, plus 2 times oxygen, which is 32.00, off the table, I would come to the conclusion that carbon dioxide has a molar mass of 44.01 grams per 1 mole. Now I have a starting point to try to attain the unit in my answer. Notice, I have grams on top at the end. I have grams on top now, so I don't have to do anything to get my numerator units to match what I'm looking for. Right now, I have moles on the bottom. I want liters to be on the bottom. If I'm going to make that happen, I need to cancel moles, which, as always, occurs diagonally. Little different different in this sense that we're canceling uphill instead of what we have traditionally done going downhill, but what matters is that they're opposites. Moles on top, liters on the bottom. We can put those two things together so long as there is a relationship between them. For instance, we used to do grams per mole or mole to mole, right? So long as we know what they are. There is a relationship between moles and liters of a gas so long as we are at STP. 1 mole of a gas is 22.414 liters. This allows us to cancel moles. I would get a calc. Take my 44.01 divided by 22.414, and my calculator says 1.9635. I only get 4 sig figs here, 5 sig figs here, so with 4 in my answer, I will call that 1.964 grams per liter. And that would be my density of CO2 at STP. Example number 2 says, at STP, what volume of 4.08 moles of nitrogen gas? This one, a little more in our comfort zone in terms of how we set it up because we have a number. They tell us we've got 4.08 mole of N2. I list what I'm looking for next. The question asked us for, what is the volume? There are many units of volume, but unless otherwise specified, you can assume that you're going to try to turn it into liters as we go through these. From here, start with what you're given, 4.08 mole N2. On the bottom of the first bracket, I will put mole. On top, I'm going to try to get to liters, so I would put liters there. Do I know a relationship between moles and liters? So long as we are at STP, yes I do. 1 mole is 22.414 liters. Moles cancels. 4.08 times my 22.414. My calculator says 91.449. I only get 3 sig figs from the 4.08, 5 from the 22.414. So with 3 sig figs, I will call this 91.4 liters of N2. Moving on to number 3. Number 3 says, what is the mass of a sample of hydrogen gas that occupies 18.2 liters at STP? Again, use our system that we've developed. Start with what you know. I know I've got 18.2 liters of hydrogen at STP. Figure out what I'm looking for. The question says, what mass of hydrogen? Mass always means grams. Right now, it's going to seem very redundant that I keep listing H2, H2, N2, N2. The reason I do that is because soon in this chapter, we won't just be staying with the same identity of a substance. We will do what we did before with solids and liquids, where we will convert from one substance to a different substance, and those problems always involve a balanced equation and a mole-to-mole ratio. So I want to develop good habits as we go through. Start with what we're given. 18.2 liters, hydrogen. First thing, cancel what I have on top, so liters H2. Next thing I would do is try to go to what I'm solving for, grams of H2. As you look at that, there's probably not a direct relationship that comes right off the top of your head linking grams to liters. So that means that we're not going to be able to do this in one step. You stop and think, what can I relate liters to? And we have been doing it thus far. Liters to moles. And so long as we're at STP, 1 mole has 22.414 liters. Then you try again. Cancel what is there. Moles on the bottom. Try to find what we know on top. Grams of H2. I look. Do I know a relationship between grams and moles? Sure we do. We use it all the time. We get it from the periodic table. The molar mass, 1 mole, says that 2.016 grams of hydrogen will take up 1 mole. Now we do our math in the calc. 18.2 divided by 22.414 times 2.016. The calculator says 1.6369. I get 3 sig figs here, 5 here, 4 here. That means 3 sig figs in my answer. So with 3 sig figs, this becomes 1.64 grams of H2. Last example from this section says, what is the molar mass of a gas that has a mass of 2.00 grams and a volume of 1.50 liters at STP? We try to set this up the same way, but a little difference than these other ones. I now have 2 numbers given to me. That's okay, we will just list both of those numbers. First number that I was given was 2.00 grams. I don't know its identity, it just says of a gas. It also tells me that that takes up 1.50 liters of space at STP. Next, we list what we're looking for. The question asks me to find molar mass, and units are very key to this. Right? I'll talk through the different units that we'll go through, but in your notes from at school, you'll remember that we have a unit review. First unit that we talk about, mass, is usually in grams. Volume can be in one of 3 things: liters, milliliters, or centimeters cubed. Molar mass is grams per mole. Molar volume, which is a new concept we'll talk about this chapter, is liters per mole. And density will either be grams per liter, grams per milliliter, or grams per cubic centimeter. This problem asks for molar mass, so I'm going to try to convert this into grams per mole. Anytime you're presented with 2 numbers, right, you can solve this using 1 line of brackets, but you're going to have to stack these at the beginning. I have 2 options how that can happen. I can either start with the 2.00 grams over the 1.50 liters, or the reverse, 1.50 liters over the 2.00 grams. To decide which you should put on top, look to the units in your answer. My answer desires grams on top. If I already have grams, it makes sense to start with the grams on top. Now, the only thing I have to do is change the denominator from liters into moles. To do that, I'll put liters on top so that it cancels. I want moles on the bottom. Do I know a relationship between these? I sure do. 1 mole, 22.414 liters. My liters will cancel. My unit left is grams per mole, which is what I wanted. And now we do the math. Be careful here not to forget to divide by your 1.50 at the beginning, even though it's not in a bracket. 2.00 divided by 1.50 times 22.414. This leads me to a number of 29.885. Again, 3 sig figs, 3 sig figs, 5 sig figs leads me to 3, so I have to call this 29.9 grams per mole. 4 different problems, all solving for different things, but notice a main staple in each of them is the conversion from moles to liters that we now know from what we were doing earlier. If you take a look at the second overhead, you'll find a large series of questions right on here. There are 9. In class, right, the first 3 of these I had the students do on their own because they mirror what was going on in these four. Right? You should try to do the same thing. You have a good example of how each of these, right, would work as we go through. Right? So I'm going to move right on to number 4, which starts to fold in some new ideas. Just so you can check that your numbers 1 through 3 are correct. Right? Number 1, the density of ozone at STP. Right? If you do it correctly, you should take 48.00, right, grams per mole, right, divided by 22.414 liters. Right? That leads you to 2.142 grams per liter as the answer to number 1. Number 2, what is the mass of 35.7 liters, right, of CO2 at STP? Right? In that one, you would take 35.7 divided by 22.414 times 44.01, leading you to a value of 70.1 grams of CO2. And then last but not least, for number 3, what is the volume in milliliters of 6.524 grams of chlorine gas at STP? You would take your 6.524 grams of chlorine divided by 70.90 grams underneath 1 mole to get it into moles, times 22.414 liters over 1 mole, and then to convert liters to milliliters, multiply it by 1,000, which would lead me to a value of 2,062 milliliters. So hopefully you got yourself to those answers. All right, and if you're still having some struggle as you go through, maybe rewind and watch the first few examples that we did. All right, or if you're still having trouble after that, come in and get some help. All right, moving on to number 4. Number 4 says, what is the molar mass of a gas that has a density of 4.21 grams per liter at STP? If I'm going to solve this one, we do the same thing that we've been doing. I first list what I know. 4.21 grams per liter. That is at STP, and they want us to find molar mass, which is grams per mole. Not very different from the other ones we've done. The thing I want you to realize with this is when you see the fraction unit, grams per liter, I want you to understand that you can split those up and say this, 4.21 grams per 1 liter, because per anything means per one. For instance, I have 2 arms per body, meaning 2 arms per 1 body. So I can split those up and put the number 1 with the liters on the bottom. Now you take a look at where you are. I have grams on top, I want grams on top. I have liters on the bottom, I want moles on the bottom. So I am going to convert those. I put liters on top, moles on the bottom. So long as I'm at STP, I'm okay to do that. 1 mole has 22.414 liters. My liters cancels, leaving me with moles and grams. And we get our calc. 4.21 times 22.414. It gets me a value of 94.362. Again, 3 sig figs would get me 94.4 grams per mole. Moving on to number 5. 5 says, what is the molar mass of a gas that has a density of 42.1 grams per milliliter at STP? I made these problems very similar to highlight something. Whenever you're struggling doing things in your homework assignments, in graded papers, even on exams. Not so much because we can't use our notes, but when you search to find how to solve a problem, do not search through your notes at the solutions to the problems, because you don't know what the solution to that problem is. What you want to find is a question that most resembles the one that you don't know how to solve. So I made these two very similar. The only difference between these two questions is that the number given is 42.1, and it's in grams per milliliter instead of grams per liter. We are still finding molar mass, which means I want grams per mole. So I'm going to try to mirror what I did in this problem to try to get myself an answer here. First thing I did up here was I split the fraction unit up. I will do the same thing. 42.1 grams per 1 milliliter. Next thing I did was I tried to get rid of the unit on the bottom and get to the desired unit. Milliliters would go on top. We try to put moles down here, but you'll find out we don't know a relationship between milliliters and moles. So that means we'll have to do more than one step. What I do know a relationship between is milliliters and liters. 1 liter takes up 1,000 milliliters. Milliliters cancel, and I try again. Cancel my liters from the bottom by putting it on top, and I try moles a second time. This time I run into two things that I do have a relationship between. 1 mole has 22.414 liters. My unit will be the same. Grams and moles don't cancel, so we get grams per mole. And now we take our 42.1 times 1,000 times 22.414. Right, this leads us to a large number. It is 943,629.4. If you take a look at your sig figs, 3 here, the 1,000 and the 1 don't limit me. 5 here means I get 3 in my answer. Is a 9 significant? Yes. 4? Yes. 3? Yes. Will the 6 affect the 3? You bet. It's going to round it up, which would make me say 944. However, 944 is not very close to 943,629. So we have to make them closer in magnitude by adding insignificant zeros. That means no decimal point here. So you would say that the molar mass of this is 944,000 grams per mole. I know that seems like a fairly large number, not very uncommon at all. When you start looking at proteins and things that happen inside of the body, you will find many enzymes and catalysts and things of that nature that have masses up into the hundreds of thousands due to the immense amount of carbons, hydrogens, and oxygens they possess. Moving on, number 6. Number 6 says, if the mass of 421 milliliters of hexane, C6H14, is 6.1 grams at STP, what is the molar mass of the hexane? First thing I do is I list what I know. They told me I have 421 milliliters of the hexane. I also know that I've got 1.61 grams of the hexane, C6H14. The question says, find the molar mass, which means I'm looking for units of grams per mole. This takes us back to that scenario where I have two different numbers presented, and I have to decide how to stack those numbers. Again, look at your answer units, and you will see which of these makes the most sense to put on top, and hopefully your brain is telling you that it's the 1.61 grams, so that we have grams in the numerator of our problem. Making us put the the 421 milliliters on the bottom. So again, grams are good. We just need to get milliliters into moles. I'll put milliliters on top, try moles on the bottom. I don't know a relationship between those. So again, I'll convert milliliters into liters. And in a second step, convert my liters into moles because I do know a relationship between those. Liters would then cancel. Get my calculator. 1.61 divided by 421 times 1,000 times 22.414. Unit, grams, and moles don't cancel, so grams over mole. My calculator says 85.716. I get 3 sig figs, 3 sig figs, doesn't hurt me, 5 sig figs. Right? So 3 sig figs means I will say that this has a molar mass of 85.7 grams per mole. Moving on. Number 7 says if 871 milliliters of hydrogen gas has a mass of 4.25 grams, what is its molar volume? Try to attack this problem the same way as the others. List what you know. I know that I have 871 milliliters of hydrogen, and I know that it has a mass of 4.25 grams. Hydrogen is one of our Hoberfinkels, so it's an H2. List what I'm looking for. The question says, what is the molar volume? Molar volume, if you look back to your unit review, has a couple different units. The most common of those, right, which is liters per mole. On a test, I'd be very specific about what unit I wanted you to find. It would say, what is the molar volume in some sort of unit? In this one, take it to liters per mole, because that's the most common way of molar volume. Another scenario arises. For the first time, we have two numbers, and I have to decide how to stack them, but neither of their units matches the units in the answer. If that happens, what you have to do is think which unit most closely resembles the unit that you want. So when I'm trying to decide what to put on top, either milliliters or grams, you have to think which of those more closely relates to liters. Hopefully you'll come to the conclusion that milliliters is a lot closer to liters. So you will stack them by saying 871 milliliters over 4.25 grams of H2. Now we have to convert both because the numerator and the denominator are not in the correct unit. It does not matter which you change first. So for simplicity's sake, let's change the top first. I need to get rid of milliliters, which we'll put it on the bottom. I will want liters there, so I try putting liters in. Do I know a relationship? Yes, I do. 1 liter has 1,000 milliliters. So now I have the correct unit in the top. Now we work on the bottom. I have grams in the bottom, so to cancel it, I have to put it up here. I want moles in the bottom, so I put moles there. Do I know a relationship between grams and moles? Yes, I do. Off the periodic table, 1 mole has 2.016 grams. No rules that says I can't leapfrog a bracket to cancel, right? It's on top, it's on the bottom, everything's multiplied and divided, so we can do that. Grams cancel. That leaves me with liters per mole is my unit. 871 divided by 4.25 divided by 1,000 times 2.016. Right? My calc says 0.413161. I have 3 sig figs on top, 3 on the bottom, 4 here. The 1,000 doesn't hurt me, so I get 3 in my answer, so 0.413. Liters would be the molar volume of that gas. Right? Big difference. Molar mass means mass per mole, hence grams per mole. Molar volume means volume per mole, hence liters per mole. Last two. Number 8 says if 705 milliliters of nitrogen gas has the same mass, has a mass of 0.458 grams, what is the molar mass of the sample of nitrogen at STP? Number 8 resembles either more closely number 6 or number 7. Right? So as you look at that, you want to decide which of those do I think it is more similar to. Right? And if you start to set up your question, it should become apparent. I list what I know. 705 milliliters of the N2. I also know that it's 0.458 grams of N2. List my question. Question says, what is the molar mass, meaning grams per mole? So if you look, I have milliliters in grams, and I have grams per mole. Here I have milliliters in grams, I have milliliters in grams, but here I have grams per mole, here I have liters per mole, so I would expect this one to mirror what we did in number 6. So you should set that up the same way as we did. I'll let you do that, right? I'll just work it out so that you can check your answer, right? But you should set it up so that 0.458 is over 705 at the beginning, times 1,000, times the 22.414, and you would end up realizing that if you do this correctly, it is a value of 14.6 grams per mole. Again, should mirror what you had here. So give that a try and hopefully you arrive at the correct answer. Last but not least, number 9. Number 9 says, what is the identity of a diatomic gas, X2, that takes up 2.38 liters of space and has a mass of 4.03 grams at STP? Set it up the same way we always have. What do I know? What am I trying to find? What I know is that I've got 2.38 liters of the gas, and that